So now we've developed these two equations, this one and this one, that give us the velocity over a certain time interval centered at 25 seconds, one that works for, well, neither one of which works for delta t equals 0, but one is simplified. All right, so what? What can you do with that? So one thing to really to observe what the importance and power of this is. So what I've done is put into my functions now. So here's my y1 that is the original function of the problem. Now what I've put in y2 is this function here. So I have negative 1.17 over 2 times 3750. The x is playing the role of delta t here, plus 2 delta t cubed all over x. Right? And then down here on y3, I put the simplified one, negative 1.17 over 2 times 3750 plus 2 delta t squared. All right, so I put those formulas in there. So what can I do with them? So if you go back to all the work that we did, let's actually just flip back and just look at the work that we did there. Getting these intervals and getting these speeds, right? So this formula is saying I don't need to know the beginning and end point or what y is. I mean, that's built into what I did, but once I have those things in my equation, all I need to know is what delta t was. So remembering that the delta t that we're using in our formula is half of the time interval. So when we did 24.995 to 2.005, our time interval was 0.01, right? So if we go to our functions here, and so I'm also going to show you, since I put the unreduced formula as y2, right? So now what I can do in the main window is say, let's get y2 of something. So variables, y variables, functions, but now I'm going to pick y2. See, so I could have 10 different functions programmed in there. All right, so I'm going to pick y2 of, so I want half of the interval here was 0.01. I want half of that, so 0.005. And that just directly gives me exactly the number that I have here. Now it happens to have one more decimal place. I'm not sure why it did one more decimal place, but clearly it rounds to 0.003, right? This one, the interval was 0.1, so my my new delta t is going to be 0.05. So just delete that extra 0 out of there, but bing, and I get the exact same value that I had here. Right, so without having to have figured out what y of 25.5, y of 24.95 were. So in fact, you can go over this whole list. When we did, what was the interval length, remembering that you have to take half of that interval length for 5 seconds, I can do y of 2.5. So 2.5, I get negative 2201.0625. That's exactly what we had, right? So we do, we can go all the way back to the first interval that we did, where the delta t, the original delta t was 20 seconds, our new delta t is 10 seconds. So enter, put in 10, and I get negative 2310.75. That's what we have here. All right, we can go all the way back to our very first calculations where we were doing these ones, right? So for part A, when we got negative 906.75, what was the delta t? The original delta t was 20, so this is really delta t equals 10. Now I already did with delta t equals 10, I got negative 2310.75. How come that's different from what I got here? How come this delta t equals 10 gave me negative 2310.75, but this delta t equals 10 gave me 906.75? This one also, the delta t was 20, so my new delta t is 10, so I should get negative 2310.75. It's totally wrong. Why? But this one's right. 15 to 35, the delta t is 20, so my real delta t is 10, negative 2310.75. Tell me why, of these three intervals, that all have delta t equals 20, our formula that we used gave the correct answer for this interval, but not the other two intervals. Please pause the video and write down your answer. Why did our formula work for this interval And it worked for every single interval except these two. Why? All right, hopefully you've had a chance to answer that question, and hopefully you figured it out. The answer is because all of our work here depended on that A is 25 minus delta t and B is 25 plus delta t, meaning that the interval was centered at 25. And all of our calculations used that 25 all the way through. So these calculations are only valid when the interval is centered at 25, and our first two intervals that we did were not centered at 25. They were centered at, this one's centered at, 15 or something? And this one's centered at 35. So that's why our math didn't work for those. All right, so that's a demonstration of how the formulas that we use are able to generate all these numbers without doing quite as much work. And then we can use that formula to do our next bit, which is number 10, where we're going to use delta t equals 0.005. This is the new delta t, I hope. I didn't really specify. Yeah, I guess this is a delta t equals, is the half length of the interval, so we can do those. Anyway, it doesn't really matter. You're going to get to the same place anyway. Yeah, so what's the difference between the two equations is that if I do the simplified equation, which was y3, so if I do variables, y variables, and do y3, if I do that using any of my known intervals, like the 10 second, so I could do y3 of 5, all right, I'm going to get the same answer that I had by calculating it. So the difference between the two is if I do y3 of 0, it gives me a value, negative 2193.75. But if I do y2 of 0, what's going to happen? You know what's going to happen. I get error divide by 0. You can't divide by 0. So, yeah, so what's tantalizing is that these numbers seem to approach negative 2193.75, and I know that I can't use this formula when delta t equals 0. But if I do, I get the value that the numbers seem to be approaching. And that is the essence of what we're looking at today and trying to understand what that means and it's telling us.